So, simple, stable, on-demand Selenium. Hi everyone, I'm Deiwin. I still haven't introduced myself. Some of you may know me from a previous Dev Guild event where I talked about branch deployments and how we deliver changes and value to our customers. Today I'm going to talk about a pretty similar topic, pretty much related. It's about end-to-end testing and more specifically Selenium-powered end-to-end testing. Before I go into the talk though, I want to introduce myself a bit more. It's always interesting trying to find a good way to, in a few sentences, explain yourself, describe yourself to an audience. I've tried talking about my past experience, professional experience, about hobbies. I tried making jokes, using that doesn't work. And this time I thought I'd try something different. And you know how they say that you become the people you surround yourself with, right? So I think books are a great way to surround yourself with great people, or at least the ideas of great people. So here are some books that I've read this year. So if you recognize any of them, then you have a decent idea of where I am or where my mind is most of the time right now. And if you do recognize any of these titles, have read it recently or have thoughts about it, then I'll be sticking around later for a bit. Come talk to me and share your thoughts. Alright, Selenium. Let's talk Selenium. Who knows what Selenium is? About half, I would say. So I made this mistake once, I'm not going to do it twice, and then explain what Selenium is. Selenium itself, the project describes itself as a suite of tools to automate web browsers across many platforms. So, as a quick example, you say, give me a Firefox, go to Google, find the search field, type something, wix.net. So you can do stuff like this. You can spin up a browser and you can do things with it. And you can do it in code. So that's what Selenium is. And Selenium is great. It's wonderful. The people I work with, they often face a decision. They have to decide, am I going to push this button or not? And if they mess up, then within seconds, tens of thousands of experiences can be ruined. And not only that, but a lot of money can be lost for many parties as well. So, what button am I talking about? It's the deploy button. Do I push my changes to production or not? And often, with deploys, it's also when you push the button and the time between pushing the button and when you can see that you messed something up, there's this short period that causes a lot of anxiety. So it's not an easy button to push. So what do engineers at Glia do? They click that button with confidence, and they do it like many times a day, whether it's peak traffic or it's holiday lull. So why are they confident in doing that? A big part of it is Selenium. There's a lot of things that need to be right to build this kind of confidence, a lot of trust in the system, and a big part of it for us are Selenium tests. So for every deploy we do, we run, of course there's a lot of other tests as well, but then there's specific end-to-end tests that cover the service or the product you're deploying. And these are run before every deploy, and if those are green, you have pretty high confidence in pushing your changes forward. In addition to that, we have this a bigger suite of tests, more than 1,000 tests that runs on different browser combinations and so on, that we run every 2 hours. And it is wonderful for catching these nasty regressions, some kind of feature that you didn't even know about. The person who wrote it isn't with the company for the last 3 years anymore. the feature, you haven't even seen it once, but suddenly you break it and you catch it before you push it to production because that person who built the feature also left a nice test for you. And another aspect of Selenium and why it's good is live monitoring. We run a smaller suite of tests against our production and production-like environments every minute, and we check from the end user's perspective if everything is up and running as they would expect it to be. So, yeah, Selenium is great. It provides all these benefits, except when it is not. So this is a graph from earlier this year, 2019. Back in April, we were at 35% for the success rate of the big suite that I mentioned before. So all of these thousand more tests that run against different browser combinations, if any of these fails, then we consider the whole suite a failure. And at that point, the suite was succeeding only at like 35% of the time. So when you get into that sort of a situation, then a lot of the benefits that I mentioned before, you start losing them. People aren't that confident in the test suite anymore. They start to ignore it. If something fails, they're not going to look into what the problem was. They're just going to rerun the thing. And the things get worse because if you're just rerunning the failures, then nobody's fixing them. They accumulate, and then they become harder to pin down later as well. So it's not a good situation to be in, where people take this situation as that's the way just things are. So back in April, we saw that, okay, this is a problem, we need to solve this. So we decided to approach this problem. And what did we do? We did a couple of things. But the biggest change we did was we split things up. So if previously we had this one sort of static Selenium cluster that was running all the time, and restarted every 2 hours because things can get messy if you don't restart everything. Then instead of that, we split things up so each test had its own separate cluster. So if something goes starts requesting hundreds of browsers for whatever reason, then other tests aren't affected, and all that kind of problems, you get rid of them. A similar kind of separation that we did is the browsers themselves. They were running multiple of them, 5 to 10 usually, in a single container. So what that meant was when one browser was trying to do like a more advanced kind of automation where it hovers something and then something appears and then it clicks on it, and then another browser for another test wanted to get a screenshot of the current situation, then in that container the focus was directed to the other browser, and then the hover mechanism and everything that went away, and then you couldn't click anywhere anymore and tests fail. So to avoid these kind of problems, we separated each of the browsers into separate container. And how did we do that? So if previously we had this, as I mentioned, this one static Selenium cluster that was running all the time, that we just restarted every 2 hours to keep it sort of stable, then and tests would just connect to it. They would expect somewhere to be like a Selenium cluster. I have this URL, I'm going to connect to it and hope it's there. So instead, what happened was with the Jenkins agent that runs the test, into the same agent, we put a Selenium hub, which is the entry point for Selenium clusters. So with every test, there is its own hub. And then also the Jenkins system that we built, it also spawns up all of these browsers. based on how much browsers, different kinds of browsers, the test needs. So based on the specific demands of that specific test, we spawned up maybe like 100 Chromes and 5 Firefoxes. And then those would connect to the Selenium hub, and this is all separate from any other test. None of these resources are shared except for the underlying hosts and the network and CPU and everything they use. In terms of code from the user's perspective, this is sort of what the change looks like. If previously, let's say you had some visual tests, you would connect to this hub.selenium URL. Then instead of that, you now have in your Jenkins files where you describe your build, your tests, everything, you have this Selenium, give me 10 latest Chromes. It says, okay, here's your hub URL. And then instead of specifying that URL, you specify the one you got as an argument. And then because you can control the amount of browsers you get for your test, you can also very safely add like more parallelization to your test, because I asked for 10 browsers, I know there's 10 browsers available. And then you run your tests exactly the same way. Of course, if you make things on demand and they work, then usually it turns out there's more demand. So this is the number of machines that are running these browsers and these tests. And if usually we would start 3 machines 8 a.m. and shut them down 8 p.m., then now you can see for a while, until people come into the office, there's nothing. Then these huge peaks, these are the suites that I mentioned that run every 2 hours. Then you see in the middle of the day, people are probably trying to deploy a lot of their stuff, and there's at least one machine always running that satisfies all of the demand. Okay, so we did this, and things improved a little, but tests are still failing. And there's the underlying cause for a test can be very different. So all of what I talked about is really only about test infrastructure. So this only stabilizes the system if the failure previously was within the test infrastructure. But when a test fails, it can fail for many reasons. It could be the test infrastructure that failed. It could be the application infrastructure that failed. Maybe your service is running out of, I don't know, CPU, like it's overloaded. The test itself could be badly written. So people who write Selenium tests for the first time, they often mess up. They just try to click things and write things, but you have to be very careful in the way you write your tests, so that you check that everything is in the right state and it's stable, and only then you do actions, and this way you actually get a stable test for yourself. So it could be that test was trying to click something that wasn't wired up yet, the button wasn't enabled, it still clicked the button, and then it expects the button to do something, but the button didn't do anything, and then the next expectation fails. This is a very common scenario. And lastly, it could be that the application fails, which is why you wrote the test. You actually want to find these application failures. But the test actually can fail for a lot of other reasons as well. So splitting things up, it helped with the test infra failures, but there's still other kind of failures there. And to help with this situation, one of the things we did was we made it more easily understandable which tests are flaky. So flaky test is something that sometimes fails and sometimes passes. One thing that I didn't mention before is that we retry all of our tests 3 times because of this flakiness, and only when it fails 3 times in a row, then we consider it a real failure that's worth looking at. So sometimes you would get a failure, and if all you see is all of these green passes and then 1 failure, you don't have almost any information. Was it like a code change that broke this? or is it flaky? You don't know. But now what we did is we made it visible if the test has been retried before. So now if you see this failure, you go back and see, okay, actually it's been kind of flaky before as well, and now maybe it just failed for the first time. It failed 3 times in a row. So, okay, this isn't necessarily a new change that broke something. This is probably like a test issue, timing issue that I mentioned before, or maybe the system itself is flaky, the application. So we did this in a kind of hacky way. If you know Jenkins, and it's actually true for a lot of other tooling as well, that the JUnit, the test report format, is a pretty common way to report test results and to use them to display them in UIs and everything. The thing with the JUnit report is that it only has 3 states: skipped, passed, or failed. So you can't really specify that this test, yeah, it passed, but it was flaky. So what we did is, if a test was retried, we marked it as skipped, because we don't really get a lot of value out of the skipped state otherwise. And then, it will still retry, and once it succeeds, we still mark it green. But then in the UI, we changed the skip name here to flake or skip. And then immediately you get all of this visibility into how flaky your test has been in the past. We also built some tooling around trying to deflake a flaky test. So if you are in this situation, you see, okay, this is pretty flaky, something is wrong, then how do you find out what's wrong? We built some tooling where you can run the test and run it as many times as it takes to make it fail. And then when it fails, the test stops in that exact place where it failed, and then it just hangs there. And you can use VNC to go look at the browsers, or you can look at the application logs or something, and you can try to figure out what went wrong. So this helps with, if you know that the test is flaky, this helps with getting rid of that flake. And along the way, there's a ton of little things that came up that I think are pretty interesting, but they are also pretty technical, so I'll try to go over them briefly. And I tried this with my team, and they sort of got bored during this. So if at any one of these points you lose me, you don't understand what's happening, yell next, and I'll take the next one. And if anyone else is still interested, you can talk to me later, and I will tell you all about it. All right, so session waiting and millisecond timeouts. In configuring Selenium, you have like these 3-4 timeouts that you need to configure, and 3 of them are seconds, and 1 of them is in milliseconds. And it's not clear in any way that that's the case. So what we had was, I configured something that I thought would then be a timeout for 2 minutes. I set the number to 120. And then that was the timeout that if a test came in and the browser wasn't connected to a hub yet to satisfy that request, then it would wait for that timeout. So it worked most of the time, but sometimes things started failing. And once I looked into that, most of the time browsers connected with that within the 120 milliseconds. But that wasn't always the case. And then, I added a few zeros, and everything started working much better. Liveness probe and restart policy never. This is a pretty simple / silly one. You might need to know a bit about Kubernetes, but essentially, when we start the Selenium hub, we keep pinging it, hey, are you ready? Are you ready? Are you ready? And it doesn't say it's ready until it has browsers connected to it. And because we sometimes need to spawn new machines to add new browsers, then sometimes it takes a while for it to become ready. So the timeout for it to get ready, we had it at like 5 minutes. Rarely, but sometimes it took more than 5 minutes to have like at least one browser connect to the hub. And then what the probe does is, okay, it kills the hub, expecting it to start up again because it thinks it's in a bad state, but if it gets restarted, then it's in a healthy state. And that's true for most things in Kubernetes, but what Jenkins does with Kubernetes agents is it sets the restart policy to never, which is, it's also hidden somewhere, you don't know about it. So our own probes were killing the hub and then just left it there, dead. And tests were trying, hey, give me a browser, and the browsers were like, hey, I want to run a test, but the hub was just dead and nothing happened. There's a fun thing about Ruby and parallel threads, where I mentioned that we read-write things 3 times, but sometimes, if you have multiple browsers and they're managed by different threads, and we had this thing set to true abort an exception, then if one of the browsers, something failed there, then we started, okay, the test failed, let's try to retry the test, let's set it up again. And then, because the test failed, we also killed all the browsers, and then the other threads got exceptions. So they blew up the retry stack, and we never got the second and third retry. There's also a thing about graceful cluster downscaling. So if you have, let's say you have 3 nodes, you have a bunch of browsers running on them, but then tests finish, and now you only have like 10 browsers running on them, you need to get rid of 2 of the hosts because all of those 10 browsers can fit onto one host. So you have to stop the ones that are running on the host that you're going to delete and expect them to spawn up in the first host again. But you don't want that when your test is running, that the hosts are just killed that your test is running on. So with a little, also a hack, because Selenium doesn't have very good ways to monitor what it's doing right now, we built a system where when Kubernetes, which we use for organizing all of this, tells one of the browser pods to, hey, you need to shut down because I need to move you to another host. Then the host, it looks at are there any tests running on me on this browser? If there are, it says, yeah, okay, I'm gonna shut down, but it doesn't actually do anything. It just sleeps in a loop until this isn't the case anymore. And if there are no tests running on it, then it just shuts down and tells Kubernetes, hey, yeah, you can go ahead and do your thing. Also, this change in setup helped us to see that we were in the middle of our tests. We were just deleting all instances of a very important service for us, with no guarantees that it would spawn up again right away or anything. So we were expecting, once again, Kubernetes gives us this guarantee that when you delete things, we'll spawn new things up for you, and you can set a limit, like I always want to have at least one very important service running. But we used a very specific command that doesn't respect those rules, and just in the middle of our tests very regularly, like in the middle of every test pretty much, we were killing all of our very important services. And a small but minor thing is we fixed quite a few things with just using correct Selenium logic, where you wait until a certain situation is true and only then try to do actions, because of the deflator and everything that I showed before. Alright, so we did all of this. We started in April. How did it go? This is beginning of July. It seemed like things are going pretty well. The last 20 runs are all green. The trend line of the graph is going up. Not seeing failures anymore. And then, everything's good. This is the July part that I showed. Then I go on vacation. Things drop a little. So yeah, this is to show that stable Selenium can be sort of an oxymoron. I don't know if it's actually possible to have a stable Selenium setup, but we're getting better, and we're also getting a lot more usage out of Selenium with the new setup. So all in all, I think things are improving. Some of the challenges that we still face. Most of our UI stuff still goes through a process where you have to merge your changes and then wait for the next 2-hour run to start. And then if something fails, then you know, okay, I broke something. We have a lot of things that are in a much better situation where, you know, your change is deployed to an environment, everything else is blocked. You run your tests very specific to that change. You roll it the change back, and you know if it works or not. And then only after that you can, you know, deploy and merge this thing. But for UI stuff, we still have this process where essentially you have to sit and wait, and you don't always do that. You don't have 2 hours to just sit and wait. So what happens is, okay, test fails. We have, for every team, we have somebody, we call them caretakers, who's on duty, and if a test fails, they're gonna go and look at it, and then they try to find out, okay, was it the recent change? They have to look at what was changed recently. Or maybe it's a flaky test, okay, this has always been this way, I'm gonna stabilize this. So this is still causing a lot of problems for us, and is one of the major causes for the instability right now. Occasional testing for failures. So there's still some things that we haven't been able to track down, where, you know, things start up. If you look at the logs, the Selenium hub is running, the browsers are running, the tests are running, but nothing happens. Nobody can talk to anyone. Not sure yet what the cause is, but you know, those are always interesting to find out. And another thing is understanding of the tooling. So I showed you the deflaker, for example. I built this, I showed this once to all the developers. It hasn't been used very much, only occasionally by specific engineers. So there's some work to do in trying to understand how our Selenium setup works and how to use it well. And I think that's most of it. Thank you. Do you have any questions?
So you mentioned JUnit, so you're writing in Java, right?
No. JUnit, like report format, is the format we use to export the test results so that Jenkins can understand them and can show them in the UI in a nice way.
Your code is actually
in Ruby. Yeah.
Did you try Selenium to work with Kubernetes and scale by request?
Right. So, who doesn't know about this? Selenium is a Selenium sort of fork kind of implementation made by Zalando. It's a kind of different concept to this. It's where you still have a single hub, but every time a test connects to the hub to ask for a browser, then the hub, you know, spawns up the browser on demand, and then satisfies that request. Yeah, we looked at Selenium, but that would have been a much bigger migration for us. So this, all that I talked about, was kind of not too much on the side hacking by me alone. Selenium would be more complex because we have our own specific browsers that we use, browser images that are built based on the standard Selenium Docker, so the community version of the Selenium Docker images, and they're not compatible with the Selenium setup. And we do this because, you know, we want to test Chrome Beta, which the Selenium community doesn't support by default, and some older versions of the browsers as well, some specific one. Yeah.
One question. Do you write tests straightforward in Selenium, or you use some Gherkin scenarios?
We use Capybara in Ruby, if you know about.
Actually, the second question
Yep.
is, you said that you're spawning so much browsers, and are those browsers like the front-end application, is that connected to some kind of backend?
Yep.
Don't you spam backend that much for running?
Yeah, but our service can take it.
It's not that as much about testing the backend, not the front-end.
Right, yeah, but I mentioned like if a test fails, it can be a couple of things. It could be testing for application infra and test or the application. So like in that case, if we overrun the service, that would be application infra stuff. And this is generally not a problem for us. We used to have a bit more of this because we used to run the same browsers and the tests on the same nodes that the application ran on. And so the browsers take a lot of CPU and then overwhelm the actual application, and that was pretty noisy, and then you don't know what caused the problem. So that was something we did some time ago where we split those things up.
Okay.
But yeah, we don't have a huge cluster for the test environment, and it's been handling the load just fine. This isn't it. Yep.
You mentioned you have a lot of tests. I was wondering, do you have something like to find out which test is tied to some feature? Like you could have, I would say like some interleaving features, which like it tests some feature, but it also needs to do something with other feature. Is there a way to find all those tests which are like related to some like feature?
We don't have that. We have a pretty simple system. We have like folder structures that are based on sort of the area or the component or feature, and then if you deploy project, you run the tests for that folder, and usually it has everything in it. So we don't have any advanced systems for automatically detecting this.
Okay.
Is there more questions? Kitchen? No? Alright. Thank you.